An object is dropped from rest 2 meters from a horizontal surface. How fast was it going when it hit the ground? Okay, so we're going to look at this. This is the first problem type for projectile motion, but in this problem, an object is being dropped from rest. So you have an object that is starting from rest, so the initial velocity is equal to 0, and you let it go, so it free falls downward. The initial velocity is equal to 0 meters per second. Gravity is always acting on it in the downward direction, and that value is equal to 9.81 meters per second squared. How far does it have to fall?
2 meters.
2 meters. Alright, and we do not know the final velocity at which it's going to impact the ground, and we don't know the time at which it's going to take the fall. So let's go ahead and try to figure out what these two will be equal to. Normally I just go straight down the equation list. For instance, VF is equal to VI minus GT. Now, this is going to be plus because it's going with gravity, so plus GT. And we don't know final velocity, we don't know time, so we cannot use this equation. So you can't start out with the first equation on the list because you don't know two of the variables in the first equation. Then I usually just randomly go to another equation. VF squared is equal to VI squared, and it's plus because it's going down with gravity to GD. Okay, we don't know VF, we do know VI, but that's equal to 0. We know gravity, we know the height, which is the distance at which it's going to fall. So we can use this equation because there's only one variable missing. VI is equal to 0, so VF squared is just equal to 2 times gravity times the distance. And VF is equal to the square root of 2 times gravity times the distance. Go ahead and get out your calculators if you have them. Final velocity is going to be equal to the square root of 2 times gravity is 9.81, and the distance that it's going to fall is the 2 meters. So it's going to be 4 times 9.81, and then take the square root. What's the final velocity? 6.3. 6.3? Alright. Alright, so that's the final velocity. How fast was it going when it hit the ground? Okay, good. We can solve for the time. Let's go ahead and do that just as an example. We take this equation, VF is equal to VI plus GT, and now we know VF, so we can solve for time. VF minus VI is equal to GT, so time is going to be equal to VF minus VI divided by G, and so time will be equal to 6.3 minus 0 over 9.81. Someone divide out 6.3 divided by 9.81. 0.64. 0.64. Alright, so we're going to write 0.64 seconds, and that's number 1.